Today's keynote is an education pioneer at the Raspberry Pi Foundation, chair of the UK's Computing at Schools #Include initiative, author of Adventures in Raspberry Pi, and a member of the board of directors for the Python Software Foundation. Over to Carrie Anne.
Thank you. Hi. So, apologies, I was expecting to give an hour's talk and I've got half an hour. So I'm going to probably skip through some of this and I might start speeding up and talking really fast. This probably won't be a problem with you guys because we speak the same language, but when I did this at EuroPython, there was a lot of people leaning forward kind of going, what is she saying? But anyway, so this is me. My name is Carrie Anne. That was a really wonderful introduction. I don't need to say any more because this is me. But if I was to sum myself up in one word, if someone came up to me and said, what do you describe yourself as? I would say an educator, right? Whether that's educating through a book, through online tutorials on raspberrypi.org, or through conferences. I'm hoping to educate you in this session today. That's what I would call myself. And right now, I work for the Raspberry Pi Foundation full-time. And something that always surprises me when I talk about Raspberry Pi is people think we're a tech company all the time. At EuroPython, I had about 6 conversations before my keynote, and every single one was kind of expecting me to sell them this product. And actually, we're a charity. The Raspberry Pi Foundation is a charity. We're funded in a really unique way in that we produce this single board computer. And the profits, the very minimal amount of profits we get from that, feeds the charity. So we're very lucky in that we've sold over 5 million Raspberry Pis, so we're kind of doing all right. But our whole goal is not about selling a product. Our goal and our aim and our mission is to educate children and adults, particularly in the fields of computers and computer science. But we don't stop there. We also believe in related subjects, things like science, arts, digital making. I think computer science underpins all these subjects and is really important. So basically what I do in my day job is I spend a lot of time thinking about how children learn. And watching how children learn, and not just children, but adults too. Like, how do they interact with a computer? What's their first experience of Python? And really, that's what I want to talk to you about today. I'm going to say some things to you as developers that you're going to kind of question, and that's good. But please bear with me. I promise this comes from a good place. So this is me teaching. This is proof that I was once a teacher. Here you can see children looking up to me as I impart wisdom to them by pointing at a computer screen. Yeah, that happened every day, I swear. Here's a more realistic picture of in a classroom at the front with some students. And so this was me. I left teaching in 2013, and I'm now on the board of directors for the PSF. Like, how did that happen, right? That should be like, what? Well, it's true, and I think that's testament to what a fantastic community the Python community is that that's happened. So there I was just teaching, having a good old time with my students. And then in about 2010, 2011, 2 major things happened. The first one in the UK was that Eric Schmidt from Google gave a speech in which he said that the kind of intake that they were getting at Google of engineers was getting worse and worse. They were struggling to find software developers that they could employ. And he kind of put the blame directly on the education system in the UK. They said that what we were teaching children in IT lessons was how to be consumers of technology rather than creators of technology, and that was a problem. And he kind of also went on to say that really we were kind of like selling children Microsoft products, really, that's what we were doing. And then kind of shortly after that, Michael Gove at the time was the UK Secretary for Education. He stood up and he gave a similar kind of speech in which he said, well, actually what we're going to do is we're going to scrap the national curriculum and we're going to bring in a new one. So if you're not aware of what's happened, I know last year Dr. James Curran kind of spoke to you as a conference, and he kind of touched on this at the end. I believe he said it was, we had really pushed the boat out and we were quite scary. But this is what our curriculum kind of consists of. This is a kind of cut-down version for you guys. From the age of 5, children will learn to code and program. And that means they need to understand algorithms, sequencing, selection, and repetition. I always make this point. This does not mean we are teaching C or assembler to 5-year-olds, okay? This can be achieved without ever going near a computer. So that's good news. Then from the age of 11, children need to have an understanding and have used at least 2 programming languages. One can be visual. So you may have heard of Scratch. That's a very popular kind of learning platform for learning computational thinking. But the second one has to be text-based. And this is where Python, can step in and really, solve some problems here. And we're seeing in the UK that a lot of teachers are picking up Python and using it in the classroom. And they need to be able to solve computational problems. That's the whole point of this curriculum. It's not to teach coding. We keep hearing this word in England all the time, this coding curriculum. It's turning into a bit of a fad word. That's not what it's about. It's about teaching children to be creative problem solvers. And so that's kind of what we've got at the moment. And just to kind of give you some kind of geography about where else in the world this kind of stuff is happening. So obviously in England, Estonia also have introduced computer science into their curriculum, so they now teach it. You guys are kind of, so before I came to this conference, I met some Australian teachers in the States at a conference, and they were kind of pretty much like, yes, we've got a curriculum coming. I saw the keynote last year from James Curran. It was kind of like, this is coming. Since I've been here, I've been talking to people, and people are like, it's not coming. So I'm not sure if it is or it isn't. But my understanding is that there is in a process at the moment. It's somewhere. It may be stuck somewhere, but it could potentially be here, right? New Zealand is kind of similar in that respect. But one place that's really interesting is Israel. Israel have included computer science in their curriculum for the last 10 or 15 years. Wow, good for them, right? And when I was doing some research on this yesterday, South Korea are also in a process of reviewing their curriculum. And what's a really important point to make here, the first one is, and this happened after my keynote EuroPython, lots of people came up to me and said, when is my country going to have a new curriculum, like Germany or France? Or just to let you know, I do not have a direct line to all the governments around the globe. So I cannot answer that question. I wish I did, but I don't. I kind of like this idea of the bat signal, but it's like a Raspberry Pi logo, and then I just appear. But that hasn't happened yet. And then the other important point to make is, like you guys, you have territories, right? So in the UK, we're made up of a bunch of countries, the devolved nations. So this curriculum only applies to England. It does not apply to Scotland. It does not apply to Wales. It does not apply to Northern Ireland. Scotland are currently reviewing their curriculum, and we're expecting them quite likely to push towards having a new national curriculum that includes computer science. So, and I think in Northern Europe, I think Denmark and Norway are quite close. I went to speak to them last year, and they seem like they. So I think this will snowball, right? I think once we've got a few nations that are doing this, I think the rest of the world will snowball into doing it. But you might think, well, why? Why should we be teaching computer science to children? What's the point? Well, these are the reasons that I think. First of all, that children are creative, they're imaginative, they're not afraid of failure. Something that we do as adults is we train children out of this mindset, right? So they're really inquisitive, they'll press all the buttons, they'll click all the things, and actually we teach them that's wrong. And so by the time it got to me at age 11, in my classroom, I would find that they would sit at a computer with a dialog box open in front of them with their hand up, and they would sit there quite happily for 20 minutes not doing anything, because they've been trained and told in their primary education, don't click the box, you might break something. And that's completely wrong. Right? It's the wrong way around. They should click all the boxes. They should break all the things. That's how we learn. I also think that computer science is a vehicle for social mobility. There's some really crazy statistics about kids who want to be professional footballers, that the top 1% in a school won't make it, the top 1% in a borough won't make it, the top 1% in a county, and you can go upwards, will not make it as professional footballers. And yet computer science, the jobs industry at the moment is just desperate for good developers, and they'll earn a good wage. So actually this subject can move children out of poverty and into really well-paid jobs, and that's interesting to me. It's empowering for no other reason than this. We don't expect every child will become a software developer just because we've taught them some computational thinking, but hopefully it will empower them to be able to solve everyday problems in a new and interesting way. I also am a strong believer in diversity in technology. Right now, the people who create technology don't represent the people who are using technology, right? Especially when only 16% of IT specialists are women, 16% in the UK. That's not really that great. And it's similar around the world. So I think diversity is really important. And then the last one is this one. And this is a reference to a video by a YouTuber called CGP Grey. And he talks about economy, he makes videos, educational videos about economy and humanities. And he made this video called Humans Need Not Apply. And I recommend everyone goes and watches it. And it's this idea that actually, if you look around us, everything is becoming automated. Right? So I was at Melbourne Airport on my way here, and I had to self-check in on a machine. It printed my boarding pass and my luggage label. I had to take it over to a machine and put it, no one else was doing it, it was all me through a computer. Supermarkets, when you check out, you use self-checkout, right? Self-driving cars. All of this automation is going to put a whole bunch of people out of work. If we just take self-driving cars as an example, just think about all the lorry drivers or the bus drivers, right? If all these people tomorrow become unemployed, that's a real problem for our economy, worldwide. And there's some crazy statistics he has in that video about actually unemployment only has to rise by a very small amount, and it can be devastating. And he's quite negative about this, but I feel that actually if we empower our children and we teach them computational thinking, that they could grow up to work on these machines, make them better, write the software for them, fix the machines when they go wrong, and actually have a job. But really we're at the point now where I don't need to make this argument anymore, certainly not in England. I think we're past this argument. I think a lot of people agree that we should be teaching computing. I imagine a lot of you are quite, you think the same, that we should be teaching this to our children. So now we're focusing on how best should we teach this? What's the best way? Which brings us to why is Python the language that we should be using to teach computer science? Well, for the first reason is that it's used all over the world, and it's used in real-world situations, right? It's a really good language that is used not just to teach and to learn, but it's also used by CERN and NASA and Google and all these companies that use it. So it's powerful enough to be used in real development. And of course, it has this really simple syntax, right? And that's what makes it a really great language to use. And we're finding that in education. So when I was growing up, I had something called a BBC Micro. And so I learn't a programming language called BASIC. And one of the best things about that was you just typed the word print and then hello world, and then it would do something. Lots of other programming languages to get started, your hello world can be 6 lines long, right? With curly braces and colons and so on. And that's not helpful, and it will put a lot of people off. But of course with Python we know it's really simple, it's 1 line. And that's what makes it really exciting for educators to use. And the last one, which I think is the most important, is that Python has the most helpful community I've ever come across in my life. How did I ever get to be on the board if it wasn't for this community? And so we're finding that for teachers and for young people who want to learn, developers are reaching out and helping, either through code clubs, volunteering at coder dojos and code clubs, or by sitting with teachers at conferences and working with them, or just through online support. So it's got the best community, and this is what will really help people. So education at conferences. Something that we've been doing in the UK for about 4 years now at PyCon UK is we always have an education summit as part of that. So when I first went in 2012, I want to say, I was invited along when I was still teaching, and I was quite new to Python, and they taught me my first programming skills in Python. They taught me my first program. But also, I found that there was roughly about 10 teachers there at the time, and mostly developers. And by the end of the first day, I was pretty much running the thing because I was one of the only teachers. But we've seen that grow now. So this year, we've opened it up again for teachers. We have our conference in September. We've got 40 teachers who are coming. And one thing that we do is we get sponsorship from Bank of America, who give us money, so we're able to release the teachers from school so they're able to come to the conference and take part in training. This year at EuroPython, we had our first ever education summit, which was great fun, which I was involved in helping with, and so that was the first one. Here we had our first education mini-conference yesterday, which was fantastic, organised by Nick, who I think I don't think we've clapped you enough today, so I think we should give you another round of applause. It's one of the best I've been to, actually, because it was full of teachers talking about what they do in their practice. So if you are here next year and it goes on again next year, I really recommend as developers you go along, because you'll learn so much from the teachers who will talk about what the challenges are for them in their classroom or what they've been doing, and you may be quite surprised by that. And also in PyCon Montreal, they had an education track as well, which I wasn't able to go to, but I managed to present via the wonders of Skype. So I think right now there's a whole bunch of barriers for Python in education. And so what I want to do is kind of go through some of these barriers, and I want to talk about some solutions that I think I've got that I'm going to need your help with. So the first one is this idea of transitioning from a visual programming language to a text-based programming language. A lot of people find with children that they love Scratch, right? They love using these clicky blocks that you put together and you make stuff happen. Someone gave a talk yesterday about how actually they saw Scratch is actually causing them more problems than it's doing good because it doesn't really teach children anything about syntax. It's just clipping some blocks together. It does teach them logic and it teaches them ideas about algorithms and sequencing and so on. But moving them onto a text-based programming language can be quite difficult because they love Scratch and it's a really comfortable place for children to be. And their first interaction with Python can be quite difficult. So we're working at the moment with the University of Cambridge to develop a kind of a game-based environment where children have to write Python text to solve problems in this game that will move a little monkey around. It's called Project Pyland, and that's kind of one solution. But we're not quite there yet. We need to find a way to move children on. Okay, this thing about Python 2, Python 3. Oh my God. This is the answer, okay? If anyone wants to know. So Python 3 is the answer. So I know some of you are not going to like me delving into this argument, but for education, just for education, there is no reason why we shouldn't be teaching Python 3 to children. Right? Actually, this Python 2, Python 3 problem causes so many issues for children. When they write something, they've seen a tutorial online, they've copied it, or they've tried, and they bring it to me, and I'm stuck, miss, it's not working. You're like, oh, that's in Python 2, you've got Python 2 syntax there, you've got Python 3 syntax there, it's not going to work. And it just confuses them, and there's no need, right? We were at a point where dependent packages and so on were in Python 2, and that's where the issue was, but we're not there anymore, right? We're just not, and so I don't think there's any reason why we shouldn't be using Python 3 in education. At the Raspberry Pi Foundation, we've made a decision that all of our resources will be written in Python 3, and we strongly encourage other people to write them so that they are Python 3 as well. And we're seeing that across other organizations as well. So what am I up to? Right, so the syntax function naming problem. Okay, so this is where I get into grounds where some of you may get a little bit upset, but bear with me, okay? So children are very interesting. They're not only learning about computer science and learning new programs and learning Python syntax, but they're also learning to read and write, right? And we should be aware of that and think about that. And sometimes when we write libraries, we use kind of function names that make sense to us, because we're adults. But what we need to be aware of is sometimes that children are using those libraries too. So let me just give you a bit of a backstory about a particular library that's called rpy.gpio. So on a Raspberry Pi, we have these pins, which you can control real-world objects with, and we use a Python library to do that. The guy who wrote this Python library is called Ben Crosden. In the UK, he wrote the library because he runs a brewery, and he wanted to control the temperature of his brewery, right? So he made this library for himself for this particular problem. But then what happened, of course, is the entire Raspberry Pi community started using it for all Raspberry Pi kind of GPIO projects because it's a great library. And of course, children are using it. We're showing children how to use it to turn on and off LEDs, and they love it. But the problem is it's not great for beginners, and it's not consistent. Right? It uses a lot of capital letters sometimes, and then it changes its mind and uses lowercase for other things, and it's really not clear. So we need to try and avoid that problem. One of the most common problems I find with beginner learners as well is quite often if we're doing something with a library that's called, I don't know, say like the PyCamera library, we have a camera for the Raspberry Pi, and there's a Python library for that called PyCamera, is that when people write their first program, they save it as pycamera.py, which is the same name as the library. Right? And to you, you're like, oh, well, obvious, duh. They're beginners. They don't know that, right? And it's a really common problem, a real common mistake. Yeah, lots of inconsistencies between like camel case and snake case. I understand that there are kind of conventions for this about classes and methods and so on, but I would really recommend that you try and stick to snake case where possible. Just try and keep your libraries as consistent as possible because you just don't know who's going to be using them. And then guessable names. I think this is really important as well. Like, with children, you want them to solve problems. You don't want to give them the answer all the time. When they're writing programs, they might get to a point where they want to customize a little bit. And you want to get them to a point where they're almost guessing what that next bit could be. Someone gave an example yesterday where they used upper to turn some text into uppercase. And then the student asked the student, like, well, how do you think we could put this into lowercase? And he was like, lower? It's like, yeah, that's right. What you don't want is for the actual, to go from something that says like dot upper to like to dot lowercase in capital letters, underscore, something else, right? And I see this all the time in libraries, all the time. So consistency is really important. You never know who's going to be using it. So I'm going to use another example, which is on Raspberry Pi, we have an API for Minecraft. It's called Minecraft Pi, where children are able to program the Minecraft world. And so this is just a very small program that I've written here to demonstrate. And so it was written by, I think, an intern at Mojang at the time. It was just kind of like a little project someone did. I think they were a Java programmer because like some of the things that are in this library are just really inconsistent, don't make any sense to me. So it might be why. And so here you can see the first 2 lines are just setting up the program, connecting to the Minecraft world. Actually, a lot of children fall down in that first line just with the capital letter for Minecraft, right? We understand why that's needed, and we get that. And actually, it's not too bad, because with children, at least you can say, well, it's capital letter at the start of the word, that's okay. The problem comes when the capital letter is in the middle of the word. Like, if you look at the last line, it says set pos, right? To us, we can guess that that's like set position of the player, right? We're adults. To children, that means nothing to them. It really doesn't mean anything to them. It can be quite confusing. So what I want to show you is, so here's a line in Python. What I'm going to show you is something a friend has taken, and they're doing an API, but they're doing it in Ruby. So just ignore that it's Ruby, right? Ignore that it's Ruby. But just look at the words that they're using for naming their functions, right? So instead of having set pos, right, they've used the word teleport, because it's a nicer word, all lowercase. And you can see here they've just used underscores. Because this person has worked with a lot of children, they see where they fall down. And I think this word is nicer, right? Teleport this person to these locations, to these coordinates. Quite nice. Okay, so here's another example. In Minecraft, you can set the blocks. I don't know if you know, in Minecraft, you have different types of blocks. You can have glass, you can have dirt, you can have air, you can have melon. That's 108, by the way, just saying. TNT is 46. So all these blocks have ID numbers, and as you can see, I kind of need to know those ID numbers in Python. Or you can do something like this, where you put it into a variable name, and then you call it later on. But that can be quite complicated and a bit long-winded. And so again, from the same guy, so what he did, he's just got rid of the numbers, got rid of this really long, having to put it into a variable. He just put in all of the names instead, so glass, air, so on. So it's much easier to call it. So it's just thinking about who's going to be using the library and what will make sense to them and keeping it consistent. Yeah, so that's kind of the naming problem. Something I want to quickly talk about is Pygame 0. This is a really great library for children to use. So I don't know if any of you know the Pygame library. It's a really great library to get, and children are really interested in it, right? Because you want to do something really visual with children. That's why they love Scratch. They want to do something visual. But what educators find with Pygame is, first of all, it's a library. It's no longer maintained. So it's a bit out of date. And it's not really intuitive. It's quite difficult to get to grips with. There's a lot of event handling, right? You'd have to teach children that first of all for them to understand how to do things. So at PyCon UK, what we do is we have like a kids' day, we have a teacher's day. And what's really nice, it's not like in a separate closed-off room. We try and make it as inclusive as possible, so developers will see then, they'll wander in and see what the children are doing and what the teachers are doing. And so there's this fantastic developer called Daniel Pope in London, and he came along and he was having a conversation with some teachers about Pygame. And he was saying how it's such a great library and teachers should use it. And the teacher said, well, actually, it's really difficult. And he was like, no, it's not. Let me just this is like a real introduction, like a piece of code you could give them. It was 16 lines long. And that teacher said, there's no way I could use that. And it's in Python too. And so Dan went away and he thought about it and he came up with Pygame 0. So what he's done, and it's only in Python 3, is he's created this zero boilerplate kind of framework for Pygame, which means teachers can teach things like sequence and conditionals and loops and use this fantastic library to create something that's quite visual without having to go into lots of detail. So there is some magic there, but it's not too magic, right? It's just a stepping stone to get somewhere. So children can write just a few lines of code and make some really meaningful progress. Okay, so my friend Sam Aaron, he always uses this example when he's talking, is that sometimes you'll be working with children, and you'll say to them, what do you want to do? And they say, well, I want to make a game. And you're like, great, okay, we can do that. Pie game, yes, we're going to make a game. What do you want your game to be like? Well, so I want it to be in space, and I want it to be some stars, and there's going to be some planets. There's possibly going to be some aliens, and there's going to be some shooting and some firing, and like space bombs and so on. And you'll go, whoa, okay. So in Pygame, I can make this black square and the screen, so we'll call that space. And I can draw this little rectangle. I guess that can be like your spaceship, right? And the child is like done, because they've got Xbox, they've got, you know, all what their understanding of what computer game is different to what I can do with them with Pygame library. So it's about how can we make meaningful progress with that child very quickly and easily, and not lose that creativity and that imagination that children have. And so this is where the Pygame Zero library works really well. We're even putting it into Raspberry and package for Raspberry Pi so that children can access it. So I do recommend you go and have a look and contribute to this project. We had sprints running on it at EuroPython, so we're still kind of working on it and hacking on it. And Dan is a really great community member, and he loves lots of support, so do go and have a look. So that's kind of where we are with libraries. So I think sometimes we find that people need to install extra libraries, right? Python's quite good. It comes with a whole bunch of standard libraries, which is really helpful. It's one of the reasons why it's so popular in education. But it doesn't come with everything. And so Dan and I were talking on the first night of EuroPython. We were talking about this idea of an education bundle, so that teachers can just download Python, right? And it will include a text editor, and it will include all the libraries that they need, things like Pygame Zero, but also other libraries, things like NumPy, Python imaging library, stuff that's like extra, but instead just included in this bundle. And so it doesn't matter what platform they're on, they can just go to this one place, download this one thing, and it will help them get started. Whether they're kind of children learning on their own, or parents learning with their children, or they are people working in schools, it's just one place. It's really rare to write a piece of Python code without these dependent libraries these days, so let's try and get them into a kind of bundle. So I mentioned this at EuroPython straight after we started talking to Collabora. We talked about perhaps using Conda as a kind of way to distribute that. I don't really care what the method is, whether it's pip or it's something else, like as long as we find a way to enable schools to be able to use this. And so I'll come back to this in a bit, because I want to talk about what happened kind of after EuroPython around this area. But the kind of big thing for me that I really want to talk about is about Python text editors, right? So one of the problems we have with children when they move from visual to text-based is their first interaction with Python and with Python text editor is idle. So hands up, how many of you use idle in your everyday day-to-day development work? One person. One person. This is what children's first experience of Python, not just children, adults as well, learners, this is their first experience of Python is idle, and you guys don't even use it. What does that say? Okay? And that's a problem. And so there are lots of solutions around this. There's kind of this idea of offline versus online text editors. I think there are some fantastic online text editors at the moment. Python Anywhere is a really good example of this, and they're doing a lot of work in the UK to try and help teachers. Someone was talking about it yesterday in the education track. There's things like Trinket, Khan Academy have some online stuff, and you should all know Grok Learning, right? You're in Australia, it's an Australian product. Grok Learning is fantastic, and it's Python, and it's Python 3. But there is issues with online, right? Not all schools have access to internet, not all children have access to the internet, not all of them have the right browser enabled, this is a problem. In my school, I wouldn't have been able to use any of these. I was behind a firewall, I wouldn't have been able to use them. Some of my children who are under 13 in the UK, I wouldn't have been able to sign them up for these websites, so we just wouldn't have been able to use them in school. It doesn't mean they're not really, really good, but they wouldn't have worked for me. And it's not so easy to kind of show progression of students learning through using some of these as well. So that would be a problem. So then we've got offline IDEs, right? Everyone talks about PyCharm Education Edition, and why not, right? It's great. There's this fantastic IDE that they've developed. It's free, it's open source, we love all of that. But my argument is that it's still too bulky. If you open it up, there's too many windows, there's too many buttons. First thing you need to do is set up a project. There's just so many ways my children could fail. You know, I've got a room of 30 children. Okay, kids, you need to click on this. Now click on this. Now press this. Then do it. And this is before we've ever written any code at all. And what I want to do in my lesson is get straight down to the computational thinking. Let's teach something, not let's learn an application. And I'm not saying it's not a good product. It is a fantastic product, and I definitely think it has a place. I think for children who are perhaps 14, 15 plus, it makes sense, who are working on projects and so on, it makes sense to use a text editor like that. But kind of 8, 9, 10-year-olds, this is kind of who I want to get at. It's not really going to work for them. It's just too cluttered. It's packed full of these wonderful features, and I would argue we don't want features. Take the features away. We just want something simple. There's just too many opportunities for my children to fail. And actually, sometimes less is more. Which brings me to IDLE. So, you know, over PyCharm, I would use IDLE. And that's a problem, really. So what's good about IDLE, right? So first of all, it's really lightweight and it's really simple. Right? It's nice and simple. It has syntax highlighting. It does do some auto-indentation. I like it when you open it up, you're straight into the interpreter window. You can start doing things straight away. And I heard this yesterday repeated by other educators, which was really exciting for me. And that's why we like it. And of course, it comes bundled with Python, so it's all there. So that's kind of what's good about it. But what's bad about it? Where to start? So 2 windows, that's a problem. Going between the 2 windows is a nightmare, and children fall down on that quite often and get a bit lost. Why can't we have it all bundled in one? Which is really frustrating. The error reporting is just diabolical. I mean, we have no idea what it's trying to tell us is wrong with the code. And that's a problem for children, because they get very frustrated very quickly with IDLE. So what are some solutions? And what I'm going to do is I'm going to try and show you what I think are some good text editors that we can copy. So the first one is Sonic Pi. So I worked with a guy called Dr. Sam Aaron in Cambridge. He came to my classroom when I was teaching, and he said, I've got the Raspberry Pi to make music. Do you think we could teach with this? And I said, yes, why not? Let's give it a go. And so we drew on a whiteboard this really simple interface that we wanted to create. So again, I'm showing you a Ruby product, but forget it's Ruby, right? And what I'm going to try and do is give you a sort of live demo here. Okay, so this is the interface for Sonic Pi. You can see in this central area here, this is where we write the text. It's got line numbers. This window here is kind of like an output window, so you can see what it's doing. And down the bottom, I have all these workspaces that I can kind of switch between if I want to play around with code. And the idea of this is it just makes sound. You just write, like, play 60, and it should play a sound. So it should, there you go, you can kind of hear it playing. You can see there was some output here. At the back, can you see that text? Can you see it? Oh, don't worry, because, yep, I can make that bigger. Yeah, see that, right? And just that function of being able to make text smaller and bigger with a mouse click, I can't tell you how valuable that is in teaching, right? Like, unbelievable. And if you want to do that in IDLE, you've got to click on configure IDLE, then you have to find the right font size, and then, and if, with children, especially when we were doing our work on Raspberry Pis, they would come up to the front, they'd plug their Pi into the projector, which was really simple, but then we'd have to mess around with the settings for them to show it. So I just want a text editor. It allows me to make the text bigger and smaller. It can't be too much to ask for. And so we have like a run button, we have a stop button. This one does include like an inbuilt tutorial. It's not really necessary, but it's helpful. What I love about this one is because it's been made for music, it also has a dark mode for nightclubs. That's pretty cool. There can't be a bit of dark mode. And then some other really cool things. So again, forget it's Ruby, but don't forget it's Ruby, because here, Ruby means you don't have to indent it, this will just work, and this is one of the reasons why it's used in education, because indentation could be a problem with children, teaching them about it. But what we find is they'll write lines and lines and lines of code, and then they'll get bugs, and they don't know why. So we want them to learn about indentation, so we have this align button, which when I click it, automatically aligns the text with nice lines where we can see it, because sometimes the 4 spaces in Python can be a bit difficult for children. So just a nice way of displaying the indentation. I'm not obviously saying get rid of indentation in Python. It's very important. But there's nice ways we can actually fix this. So IDLE does have auto-indentation, but what we find is you have to be in the right place to do that, and often children will, like sometimes you'll give them example code, and so they'll go and write it somewhere else, and they won't get the indentation quite right. So having a button that kind of moves it around or helps us some way deal with that would be really helpful. And just to kind of, so error reporting, I want to show you this. So what Sam has done here, if I just try and show you an error. So if I try and run this, it will pop up and it will say you have made an error. It will show you the line that you've made an error on, and it can distinguish between a runtime error and a syntax error in nice, big, bold lettering. This is an error, this is a problem. And I think that's really nice. And just to prove that Sonic Pi is like a music platform tool, this is the kind of music you can make. This is what we do with children. And so I'm being given the please shut up warning. So I'm going to... 10 minutes, okay, right. So I can quickly show you Grok Learning then. So here's something that's a bit more Python related, right? This is online. Can we get an offline version of this? Because it would be amazing. So here you've got your panel to write your code. There's a kind of instruction tutorial on this side. But what I love is that it also has the interpreter window down the bottom, and it's completely interactive, right? I could do like, what, 5 plus 5, and it would give me an answer. I'm not typing for some reason. Okay, I don't know why it's not working. But, you know, it's completely interactive. And it has these lovely buttons that say run, it says terminal, I can save my work. Simple, stripped down, not lots of confusing features, right? That's really important. Let's quickly go back to this because I'm going to run out of time. Okay. So, I gave this keynote at EuroPython. I was a bit disturbed to find that Guido van Rossum was in my keynote. Also very, pleasantly surprised, but also terrified because I made a joke. Because 2 days before me, he gave the keynote, and he asked members of the audience to ask him questions. And someone got up and they asked him the question, "What's your favorite text editor?" So just for all you fanboys, the response, first of all, was Emacs. There was a big round of applause and then a whole bunch of booing. And then he went, "Oh, but, sometimes I use Vim." A whole load of cheering, a whole load of booing. But his answer wasn't IDLE, surprisingly. And of course, I made this joke in my keynote only to find he was sat in the audience. Damn it. But we didn't really have time to connect straight afterwards, because obviously he gets swamped with people and lots of people asking me questions. So being true geeks that we are, we started conversing via Twitter, even though we were in the same room. And so he made this tweet. He was kind of like, well, don't really waste your time trying to improve IDLE. Right, actually, maybe the best way we can do is just build something better. What I was disappointed to then find out, like a couple of days ago, is that a whole bunch of people have seen this tweet. And because I'm mentioned in the tweet, I'm getting all these responses from people who have clearly not watched my keynote, who keep saying, "Why don't you use PyCharm?" Just go and watch the keynote, and then you would know why the answer is not PyCharm. It also ended up on Reddit. There's been a whole massive conversation on Reddit about this. Not one person mentions that this comes from a keynote, or like who the hell I am in it. Because if people just watched the keynote, they would understand what we're arguing for, and then that just really frustrates me. So you're probably wondering how you can help. Of course you are. The answer is not going on Reddit. The answer is it's going to be here. So the first way you can help, right, is meeting educators. Come to if there is an education track at a conference, go to it. You will meet teachers and you will hear some really inspiring stuff, and they will blow you away. Like yesterday, they were just amazing what they were talking about, and I just found it really enjoyable to be around. Add education tracks to your conferences. So one thing we're trying to do with Python conferences is to try and ensure there's always an education track, and we're getting there. If you build it, the teachers will come. The first time, you're probably not going to get that many teachers. It was the same for us in the UK, but after a few years, that will grow and you'll get more and more teachers. Yeah, run special education sessions at your local user groups. So the London Python Dojo, they meet quite regularly. And one night I kind of came along and I brought the curriculum with me and I said, "Oh, does any of you guys want to hack on something around this?" And they made me some amazing projects that I was able to take back to the classroom. And I was just one teacher. And so they went on to have like a special education edition of that where they invited lots of teachers to come along. So I would recommend you do that if you have like a local user group or you get together. Like invite some teachers and you can help them in that way. Adopt a teacher. So when I went to the PyCon UK the first time and I was learning Python, my journey didn't end at that conference. Afterwards, I went away, I would practice and I would try and write some programs and I would fall down and get stuck. But because I'd met some developers, I just put my code into Pastebin, just sent it to them, and they would mark it for me. And they would be like, I see what you're trying to do there. 4 out of 10 for effort, but, And it was really nice, and I learned a lot through that. So that's how you can help. Adopt a teacher, help them. And continue to create and contribute to really great libraries. There are some great libraries out there, and you're doing great things. Keep it up. But for me, and this is the big one, as part of the PSF, I've helped set up a Python education working group, which is something we're moving towards on the PSF. When I announced this at EuroPython, it wasn't an official group because we weren't sure about what the response would be. The response was overwhelming. And actually, when I was on a plane over here, the PSF board had a meeting. I'm pleased to announce that it is now an official board. They approved it, which means money's coming, yes. So please join the mailing list. I've set up a mailing list for this. You'll be pleased to know Guido has already signed up for it. So there's no reason why you can't. And the idea around this is we want to actually do something about the problems and the barriers that I've shown you. So we want to make a Python text editor, right? As a community, we want to do that. So if you join that group, we're going to start having a discussion around that. We're going to have money attached to this, so we're actually able to fund development if we need to, or testing of it. So please join this mailing group. And it in no way replaces the education special interest group. That's another mailing list. That's a fantastic mailing list, and I also recommend you're part of that. That's more around discussion around education generally, and this group is about making things happen. So if you're not aware about PSF membership, if you're not a PSF member, you can sign up on python.org to be a member. And as you can see, what I've done is I've highlighted the membership level, that if you just contribute 5 hours of your time, I think it's a month. I'm looking at Nick. Is it 5 hours? He's nodding, right? So 5 hours a month of your time, and you become like a contributing member or a managing member. So if you join the working group and you contribute 5 hours of your time, you have voting rights, you have all this cool stuff as part of the PSF. So, please join my working group, I guess is what I'm getting at. So, being a good teacher, I'm going to set you some homework. The first part of your homework is obvious. It's please join the mailing list. Number 2, at PyCon in Montreal at their education track, which they didn't film, so there's no video evidence of this. So I wasn't there, so I couldn't watch it. But everyone kept telling me this guy called Al Swaggart, he gave a talk about changing IDLE, like making it better. And so on GitHub, he has like a wiki called IDLE Reimagined. And I think it's a really good starting place. There's no point to duplicate work, right? Let's go and look at what he's done. I've had a read of it. Let's contribute to that. Let's see what the problems are and how we can fix them. And then the last one is this book, this picture of a book I have up here. I think there might be a few copies lying around, but we gave them to teachers yesterday. It's a free book. My friend Nick Tollevay in the UK, he wrote this book about Python in education. It's a free book. It's definitely worth a read to give you some insight into this. And your homework is due for PyCon Australia next year. Can you get your planners out and your journals? I want to see you writing that down. I will check. So let me finish with this idea about the future. So first of all, there's this real danger at the moment that coding becomes a kind of fad, an education fad that we just do. We do this hour of code once a year. It's a fad. I'm teaching coding, pat myself on the back because I sit my students in front of a computer screen and they do something. Let's make sure that doesn't happen. Computational thinking should be part of every child's education. And I think there's a real danger that visual programming like Scratch could become it. And that's it, children just learn Scratch. So we've stopped teaching them PowerPoint, and now we're just teaching them Scratch. Scratch becomes the new PowerPoint. Let's make sure that doesn't happen, and Python can be the way we stop that from happening. There is a danger that coding will be limited to building apps. I hear this all the time. We're doing coding, we're making apps. We're using JavaScript, we're making apps. Apps, right? Like, as if that's what we do as developers, right? As if that's all there is to computer science is making apps. We need to make sure that doesn't happen too. So let's consider the possibility that we're successful. Let's just think about in 20 years' time, 25, 30 years' time, these children right now who we're trying to help by teaching them these skills. Just imagine what the world could be like when those children grow up. They're not all going to become developers, right? Some of them are going to go into medicine. Some of them are going to go into the law. Some are going to become go into parliament, right? There are all these different areas that they're going to go into. If they are able to solve problems in a really creative way, they have some understanding about open source and free software, right? What could the world be like?
It could be amazing. It really could, and I really believe that. Computer science, it could be as fundamental as kind of like reading, writing, arithmetic. You know, we make this joke in England, like Raspberry Pi could be the fourth R, that these children, it will just become every day to them. And I just think the workforce will be, I think we have a real opportunity now. And don't wait for a curriculum. Like, make it happen now. You can make it happen by volunteering, by helping out in all the ways that I've suggested. And we can make this world a much better place, and I really believe that. So I'm Carrie Anne. Please come to speak to me about any of this. I'm around today. We've probably run out of time for questions, because I do like to talk. But thank you.